Hello, good evening.
Good evening, madam.
How are you?
I'm okay. And how are you?
I'm fine.
That's good.
Are you the one who was talking about extra time?
Yeah, I was the one. Like, I just thought of maybe 1 hour will not be enough. Maybe 1 hour to make out.
You want us to finish everything today?
Uh, you mean everything? So,
Sorry?
I mean, like, everything is Excel included in it.
Yeah, because we are supposed to finish SPSS today. Then we can have another 2 hours, maybe 1 or 2 hours to do Excel, because I'm not going to dwell so much on Excel because Excel is a whole. It's a different. It has its own course, but apparently this course, when it was advertised, they added Excel. So from the start, I mentioned that I'm going to run us through Excel, but I'm not going to take a lot of time. I'm just going to run us through Excel. The assumption will be that you already have some basics in Excel. And so I'm just going to teach you how to analyze data in Excel. That's it. So it can take us 1 hour or 1 hour 30 minutes, but we'll finish doing SPSS today.
Okay, madam. And madam, I wanted to ask the differences between, or rather to say the difference between data analysis in data
Mm-hmm.
data analysis in review. What's the main difference?
The tools which are used is what the difference is.
So
The same data you can analyze
data.
it. The same data you can analyze it in Stata, and maybe the same data you can analyze it in eView. It depends with what you want to get out of that data, because those tools are different.
Okay.
The same way with when you analyze data with SPSS and when you analyze data in Excel. There are certain things that you will not be able to do in Excel that you might want to get when you use SPSS.
Okay.
Yeah.
About it, I failed to get a just that for the distance second of five.
For Stata and eView.
Yes. Now I will just in November since there is another chance.
Oh yeah, there's one that's starting on the, I think, 7th of November. Yeah. Okay, we shall begin today's class. We have so much to cover. So last time we were looking at analyzing categorical data, and we did some analysis. We came up with charts and tables, and I also showed you how to move the charts and tables from SPSS to the tool that you are working with, the tool that you are using to analyze data. It could be Microsoft Word. It could be any other, maybe you could be using Google Docs. You can use the same format to move your tables or your charts to the document that you are working with. Okay, so today we are going to go on and look at analyzing continuous data. Okay, we looked at categorical data. There are two types of data. There's data which is categorical and data which is what is continuous. Even when I was putting level of measurement here, you could see that nominal, there was nominal, and there was also what is scale. Okay, there was also supposed to be ordinal. When I click on this, you'll be able to see that there's ordinal, nominal, and scale. Okay, so usually nominal measures and ordinal measures, they usually fall under categorical data, while scale is usually what? Continuous data. So what is continuous data basically? Continuous data is numerical variables that can be what? That can assume any value within a specified what? Specified range. Okay? They can assume any value within a specified range. Okay? Continuous basically it simply means that they can be in an infinite format, they can have an infinite number of values basically. That's the other way I can say it. For instance, if you want to put a scale for the number of for how old people are, can you really come up with the maximum number of years someone can be? No, because you're not the one to determine how long that person is going to live. So that value is going to be continuous. Someone can be 100 years, can be 150 years, they can be 200 years, and they can go on and on. Okay? They can be 10 years, they can be 11, they can be 12, they can be 13, yeah? So basically those are what we call continuous variables. The other example in this data set of continuous variables I can talk about is weight. Okay? Weight is supposed to be a what? A continuous variable. Apparently this data set was not the measurement was not properly put, but it's supposed to be a scale to mean that it is a continuous variable. Okay? Weight also, you are not going to put a maximum. You cannot come up with a maximum weight for people. You can't say that, okay, we are going to say maybe the weight of this person is only going to be maybe from this number to this particular number. No, it's a continuous variable. People are going to weigh as much as they want, basically. Yeah, so that is about continuous variable. And in SPSS, you have to take note of all these things as you are analyzing your data. Okay, so in when you want to analyze continuous variable, there are certain things that you look for. When you decide that I want to use analyze continuous variables, there are certain things that you look for. For instance, you look for the center of of data. Where is the center of this data? So you're going to have this data set. So maybe, for instance, if you have a variable, maybe age, you want to when you decide to analyze it using continuous, you want to find out which part of this data is the center. Maybe you want to come up with the mean and the median. You want to find the center of the data. And the other thing that you can do with continuous variables is to find how spread the data is. How spread is that data. You can use standard deviation and variance to do that. Okay? My assumption is that you have some basic knowledge in statistics, so you should know what standard deviation and variance is. So basically, if you don't, it helps you to measure the central tendency of your data. It helps you to measure how spread your data is, basically. Okay? And then the other one that you can measure is you can try to find out if there are any extremes in your data or outliers. Okay? For instance, you are going to have maybe a data set that's ranging from maybe from 10 to 100. So maybe you have numbers from 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. And then maybe the last number, from 100, it jumps and goes to 170. Okay? Then that becomes something that's normal for that data set. So if you want to find out if there are any extremes in your data, such as this particular one that I've given as an example, you can use these measurements to do that. Okay? You can find the minimum, you can find the maximum, and you can also find the outliers in your data. Okay? So that is what we are going to look at. Okay. So in order for us to analyze data using continuous data, we go to analyze again. Okay. And then we go to what? Descriptive statistics. Okay. And if we want to use descriptives this time around, we are going to click on what? Descriptive. Okay. When you click on descriptive, you are going to have hello, someone trying to say something? Hello. Okay, I'm going to proceed. So we have when you click on I'm just going to start afresh. So I said you go under analyze. Remember last time we went under descriptive statistics and we were looking at frequencies, right? This time around we are going to look at what? Descriptives. So I'm just going to click on descriptives, and then we are going to use some of this data. We're going to use the age. Okay, we want to find we want to find the mean, the median, the minimum, and the maximum, the standard deviation, and also maybe the variance of the what? Of the variable called age. So I'm just going to click on it, then I'm going to move it here. And then maybe we can also find, we can also add what? Weight. So I'm just going to click in weight. I'm going to click weight, and then I'm also going to move it here. Okay. And then I'm going to click on options. Okay. Under options, it helps you to decide what exactly do you want to get out of this what analysis. So here mean is already checked, so I'm just going to leave it like this. We want to get the mean, and let's say there's also standard deviation here, and maybe we also want to get the variance of this data set, these two variables. I'm going to click on the what variance, and if you want the range, you can also click on the range, and then we have the maximum and we also have the minimum here. Okay, and then there's basically that's all we can get for now on this data. So I'm just going to click on continue. When I click on continue, then I'm going to click on what? Okay. Then the data is loading. We are going to see the data in the output window. And according to the experience we had last time, I'm assuming that we will not be able to see the output window. So let me just share the screen for the output window so that we can see what is here. Okay, so I'm just going to stop sharing this. Then I'm going to share the output window. So that you can see the results. Okay. All right. So this is our output window right here. Okay. We wanted to get some descriptive statistics for this data. We wanted to get the what? The range, the minimum. Okay. The minimum for how old the person with the youngest person in our data set is 18 years Okay, and then in terms of weight, the person with the lowest weight is what? Is with what? 2 kgs. Okay, and then we also have the maximum. The oldest person in our data set is 45 years old. And then in terms of weight, we have 4 here, right? Then we have the mean. We also have the mean for weight. Then we have the standard deviation, and we also have the standard deviation for what? For weight. Then we also get the variance here and also the variance here. So for our data set, this is the description for the what? For the data set that we are working with. Okay, so basically this is how you use this data if you want to find the descriptives of this data. Okay, I should also be quick to mention that you can also use frequency to find the what? All these values. Okay, you can also use frequency to find these values, but if you want to get this specific data without charts, you can easily use descriptive statistics to get this data, this information from our continuous variables. Okay, any questions so far?
No question. No question.
Okay, great. So I'm just going to go back to SPSS. I have to switch between tabs because I don't usually share the whole screen. I just share tabs. No wonder you notice that I have to switch between tabs. I avoid sharing the whole screen. Okay, so I've mentioned that you can also use frequency to do this. So I'm just going to use frequency and you will see how the data plays out. Okay. And then after that, we can start looking at cross tabulations. Okay, so I'm going to go back to analyze, then descriptive statistics, and then I'm going to click on what? On frequencies. When I click on frequencies, then we're going to choose which variables do we want to analyze. I'm going to choose age, and the other one we're analyzing was weight. So I'm also going to add what? Weight. Okay. And then if we want, we have to make sure that we get those statistics. So I'm going to click on what? On statistics. Then I'm going to, under measure of central tendency, we have the mean, median. We can also get the mode from here. You see, we can also get the mode. Then under measure of dispensation, we can also get what? Standard deviation and variance, minimum, maximum, and if we want, we can also get what? The range. Then I'm just going to click continue. Then we don't need charts for this data. We are more interested in the what? In the measure of dispensation and also measure of what? Central tendance. So I'm just gonna click OK. Okay. When I click OK, we have all the data in our what? In statistics. We actually have the data on different tables now. You saw the first one we had the same table for both, but this one we have one table for age and another table for weight, and it has all the what? The data that we need. Okay, so basically this is how you do it. Okay. All right. So now we are going to move on and look at cross tabulation. Okay. We are going to look at cross tabulation. This is the last topic we're going to look at under SPSS, since we already looked at the syntax editor. This is the last one we're going to look at. Okay. Then you would have enough to get started with SPSS. Okay. And so I'm going to talk about cross tabs. So cross tabs are sometimes called cross tabulation. They help us to find or to describe relationships between our variables. You know how we were analyzing this continuous and categorical data. We're just analyzing the data separate, like each variable we analyze it and then get all the information that we need out of the data. But if we want to compare two variables, for instance, we want to find out if there is any relationship between age and gender, or if there is any relationship between weight and marital status. That is now where cross tabulation comes in. Okay, it helps us to answer certain questions about our data set. If maybe you want to find out if there is any relationship between students between the status, the financial status of a student and how they pass, like how they perform at school. You can use cross tabulation to find that kind of a relationship. Okay, so that is what we use cross tabulation for. So it helps us to find relationships between two variables. Okay, and it can also help us to find how many times a certain combination occurs in a data. Okay, it can also help us to find that, like how many females, how many males. It can also help like to find the combination in our data sets. Okay, so basically that is what we use it for. So if you want to get a relationship between two variables, basically you use cross tabulation. And how do you find cross tabulation? The first thing you have to do is you go back to analyze. Okay, you go back to analyze, and under descriptive statistics we have cross tabs down here. Okay, we have frequencies, descriptives, explore, and we have cross tabs down here. Okay, when you click on cross tabs, you have to decide which one of your variables is going to be in the row and which one of your variables is going to be in the column. Because remember, we want to do we want to find a relationship between two variables. Okay, for instance, let's say we want to find the relationship between gender and age in our data set. Maybe we want to find out how many females were of the certain age and how many males were of a certain age. You understand that? Huh? We want to find out how many times this combination occurred. How many times we had females who were of a certain age and how many times we had males who were of a certain age. This kind of analysis is going to help you answer certain questions in your analysis as you are analyzing your data. You're going to say maybe we had this number of females. We also had this number of males. Okay, and also the number of times that combination occurred. This analysis can help you find that. Okay, so that's what we are going to do. So we are going to put we are going to start with age. We are going to put age in row. Okay, we are going to put age in row because we want to find out the gender against age. So gender is going to be in the columns, and then the row is going to have age. So I'm going to choose what is your gender, then I'm going to move it into the columns. Okay, so we have under rows we have age, Then under gender, we have what? Column. Then the other thing you look at as you decide which one is going to be in the rows and which one is going to be in the column, you look at your data set. Okay? Age. The data set for age is more spread, and it has a lot of values compared to what? To gender. Under gender, we only have 3 values, or 2 actually. Okay, someone can either be male and female. So we can have columns that's going to be male and female. And then we're going to have a combination for all the what? The ages which are available. And then we'll be able to get our results. Okay? So I'm just going to, we now have under the rows we have age, and then under the columns we have what? We have gender. Okay? Then I'm just going to click on what? I'm going to also, it's already ticked here that we want to display a clustered bar chart. So we are going to see the chart of these combinations so that we can see how many combinations are there in terms of this relationship, or if at all there is any relationship. Okay, so I'm just going to click OK. Okay, I've clicked OK. We have cross tabs here, so I'm just going to share. I'm going to share the output window so that you can see. Okay, so that is our output for cross tabs. Okay, we have a case processing here, a summary. We already know what data we're dealing with. We know that the number of variables, the number of the number of data that we are dealing with is what? 182, and we have in percentage format, it's 100% because all of our data is valid. Okay, and then we don't have, of course, we don't have any missing values. So the total percentage is 200 and the total number is 200 because our data, all of our data is valid and we don't have any missing data. Okay, and then now we have this table that is giving us the relationship that we want. We have how old are you in relation to what is your gender. Okay, so we have females here. Okay, those who are the females who are 18 years are what? They are 6. And those who are the males who are 18 years are also 6. Okay, you understand now what I meant when I said how many times a certain combination occurs? This is basically what I meant. And then we also have those who are 19 years old. Okay, the females are 10. And then the males are what? Are 5. You know, so you can explain all this in your analysis as you are writing your research. You can explain all this in your analysis. Then those who are 20, okay, those who are 20, we only have 1 female who is 20 and 11 males who are 20. Okay, then we have 6 who are 21. Then we have 5 who are what? Who are males. Who are males and what? And 21. Then under 22, we have this combination. Also, we have 5 females and 12 males. Then under 23, we also have some. 24, we also have here. 25, you know. And then we keep going like that. And a unique one here, under 35, we did not have any female who was 35 years old. And we had what? 2 males who were what? 35 years old. And even 41 years old, we did not have any female. And also 42 years old, we did not have any female. And we also have a male under 43, where we did not have any male. Okay, the last column is giving us the total number of what? Of that combination. Okay, so your data is going to be clearly what? clearly distributed or clearly outlined, so much that you're able to have a clear picture of how exactly your data set is. Okay, this helps you to make certain conclusions in your data as you are doing the analysis. Okay, so we also have what? Our chart here, which is trying to give us the distribution in terms of what? Age and gender. Okay, under the here, down here, we have how old are you, we have the distribution of what? Of the age ranges, and then on this side we have what? We have gender being depicted based on what? How old they are. Okay, from this analysis we are also able to tell that we had a lot of what? A lot of males who were 24 years, is it 23 years old? Yeah, we can also make this analysis. We can see that we had the highest number of males were what? Were 23 years old. So basically this is how we use cross tabulation. We are going to do another example so that you can see. Okay, the next variables that we are going to try to find the relationship for is weight and marital status. I think this should be interesting. We want to find out if there is any relationship between the weight of a person and their what? Their marital status, whether they are single or they are married. You know. Wait, before we move, is there any question on the first tabulation that we have done?
No question, madam.
All right. Is that the case for everyone? Okay, I'm going to assume that's the case for everyone. Okay. So we are just going to move on and look at if there is any relationship between the weight of a person and their what? Their marital status. Okay. And we are also going to assume that if people they have more, like a certain group of people have more weight, we are going to assume that maybe they are less stressed, something like that. You can make any conclusions based on your data set depending on what you're looking for. Okay, so let's try and do this so that you can see how it works. I just want to make sure that I'm showing you everything that I'm doing, so forgive me if I have to switch between the windows. SPSS just has too many windows, and it's not like these other applications where you can work on the same window and it will be shared. The way that the windows for SPSS are made, they're in such a way that they're separate from each other, except for maybe for these two views which are under this window that we are working with here. These other windows, such as the syntax editor and also the output window, they are very separate from each other. Okay, it's as if they're different files altogether. Even their file format is actually different. Okay, you can actually verify with me. You will notice that the extension for this file that we are working on right now is SAV, right? But if you check the extension for the output window, you will notice that the extension is different. Okay, the extension is usually different. So that's basically how it is. All right, so we are.
And also,
Yes.
to add on to what you have said,
Yes.
I came up with a simple statement when I was going through tableaus.
Yes.
Based on most people's.
Mm-hmm.
It says that the way SPSS was made,
Mm-hmm.
it brings out different windows when you are doing work
Yes.
to prevent confusion.
Yeah.
That was their reason, to prevent confusion, so that it brings out something different on its own page.
Yeah.
Each data set, each activity that you are doing just to come out on its own, so that you don't get confused.
Thank you very much. And actually, some of these features, they are what makes SPSS even easier to use. You know, there are a lot of data analysis tools out there, as you also have noticed. But you will notice that SPSS is the one that's widely used. Why? Because it's easier to use. And then it gives you your results. Like you don't even have to try so much. As long as you know how to get started with it, you know how to enter your data, and just to make sure that your data is properly defined, your variables are properly defined, then you will easily work with your data and you will be able to get the results that you want out of it. Okay. All right. So now we are going to find a relationship between weight and what in marital status. So we are going to go back to analyze, and we are going to go to what? To cross tabs. We click on cross tabs, and this time around, I said we are using marital status and what? And weight. Okay, so weight is going to be in our column. So I'm just going to remove these variables which we had added. You know, if you want to remove, you just click on them and you click on the arrow, and they'll go back to this other placeholder which has all the variables which are available. Okay, so I said weight is going to go under column, so I'm going to click on weight. Okay, and then I'm going to click under column here. I'm going to click on the arrow, and then for the next one we said we'll use is marital status. Okay, marital status is going to go under the rows, so I'm just going to click on marital status, and then I'm going to click here. Okay, and then we are not going to get any other statistics like the variance and all that. No, we've already done that. And I said we wanted to display a clustered bar chart, so I'm just gonna click OK. Then I'm going to go back to the output window so that we can see the results of our analysis. Okay, I hope you're able to see this. Able to see the screen?
Yes, madam.
All right, so I want us to follow through. What are we doing here? We want to find out if there is any relationship between marital status and weight. Okay? Is there a relationship whether someone has gained or they have lost weight, on whether they are married or they are single or they are divorced, or maybe they are widowed, you know, such kind of things. So basically that is what we want to get out of this data set. So the the first one we're going to look at is all right, this is the data that we are working with. All right, marital status and weight tabulation. Okay, so the first thing we're going to check is weight against what? Marital status. So we're going to start with people who are single, and then we'll see which range of the of weight do most of them fall under. Okay, which range of weight do most of them fall under? Okay, so we're going to start with those who are single. Those who are single, we have 71 people who are on 2 kg. Then we have 41 people who are on what? 3 kg, and we also have 15 who are on 4 kg. Okay, and then those who are married, we have on 2 kg we have 15, and then weight, on 3 kg we have 11, and then on 4 kg we have what? We have 5. Okay, and those who are under the categories of other, we have under 2 kg we have 7, then under 3 kg we have 10, and then under 4 kg we have what? We have 7. Okay, so from this data set, you will notice that there isn't any pattern. Do you agree with me? You're going to find that people who are single here, they have less weight, and here they are the ones with they are also a big number who are what? Who are maybe who don't weigh so much. Okay, and then here we have those who are married under 3. We have 11 here, and we also have what? 5 here. Okay, so those who are single, they actually have the highest number on all of them. And those who are married, they kind of like follow through. And those who are under other, they're like the last category. So we have the total numbers. We have 127 for the single, and then we have 31 for the married, and then we have what? 24 for the what? For the other. And then we can also try to use this analysis. Okay, we have under the underweight, we will notice that we have the highest number, meaning for all of them. If you notice, you'll notice that for almost all of them, the highest number is for those who are what? Except for the other. The highest number for here, and also the highest number for here, it's for those who are on what? On 2. The single and both the married. So you can really not make any conclusion and say maybe people who are single, they think too much, so they are not, their weight is low, and maybe those who are married, they are so happy, and so maybe their weight is high. You can't make any conclusion. So you can easily say maybe there's no relationship here. You just look at the combinations and you notice that there's no pattern, and you can be able to conclude that there's no relationship here. Okay, so we can also look at the chart. You notice that those who are single, they have the highest number on almost each and every, on all the what? The ranges of the weight that we have. And also those who are married, they follow through, and then we also have the group for other, and they also follow through. Okay, so basically this is how you do the analysis for cross tabulation. Okay.